Hello everyone. Today we are going to talk about some geology vocabularies. Let's look at the first one. The first one is coal. Coal, it is at the Earth's center, is a dense coal consisting mostly of iron, solid in the inner core and molten or liquid in the outer core. Let's look at this picture. This is the inner core, the place is here, and this is the outer core, and the place is here. And outside the core, it is the mantle, which I would like to talk about it later. There's something interesting about the core. In the core, the temperature is about 6,680 degree, and the radius for the core is about 3,470 kilometers. Let's look at the second word, the smelting, which in Chinese is the 冶炼. Smelting is a process in which ore is heated beyond its melting point and combined with other metals or chemicals in order to form a metal with desired characteristics. For example, steel is created by smelting iron ore with carbon. Here is the picture that shows the process of the smelting. There's something interesting that in the prehistoric time, or even the Shang Dynasty in Chinese history, people had already started to smelt and combine metals, like the bronze or the copper or the gold, silver, iron, and lead when still in the prehistoric time. So we could see that the smelting process actually has a very long history. Here is the third word I would like to talk about. It is the mantle, which in Chinese is the 地幔. Let's look at this picture first. Here is the places of coal. Here is the low mantle, upper mantle, and even the uppermost mantle. Mantle is surrounding the core and is a thick layer of less dense, elastic rock called the mantle. The thickness is about 2,900 kilometers. It also occupies the most volume of the whole Earth. Here is the fourth vocabulary, and it is asthenosphere, and in Chinese it is 软流圈. Asthenosphere is a portion of the upper mantle called the asthenosphere, and it contains especially soft rock, melting in some area. What that means is that in this area of asthenosphere, most rock are very soft, and it is like the liquid state. And for this asthenosphere, it is underground about 60 to 250 kilometers, and the temperature of this is about 1,300 degrees. The most important thing for the asthenosphere it is that the lithosphere plate is drifting above the asthenosphere, so it has the very critical role in the plate tectonics that I would like to talk about in the later. Let's look at another word called lithosphere. Lithosphere in Chinese is 岩石圈, and the lithosphere is the hard rock above the asthenosphere. And the lithosphere is very interesting because it includes both the uppermost mantle and the entirety of the Earth's third major layer, the crust, which we could see in this picture. That here is lithosphere, and it contains the uppermost mantle and the crust. In the lithosphere, it contains granitic rocks and basaltic rocks here. And most of our buildings and some architectures are actually built in the lithosphere for their basis. Here we would like to talk about the crust. The crust is the most thin, brittle, low-density layer of rock that covers the Earth's surface. Let's look at this picture. Here, it is the most thin, the thinnest and the lowest density layer. Something interesting, there's no crust in the Central Pacific, so this is a discontinuous layer. And for crust, it contains the continental plates and the oceanic plates. Here is a very important word, and it is called the plate tectonics. Plate tectonics in Chinese is 板块构造, and it is a very complex. We could see it in this picture here. What is plate tectonics? We know the heat from the inner layers of the Earth drives convection currents and flow in loops in the mantle, pushing the mantle's soft rock cyclically upwards as it warms and downwards as it cools, like a gigantic conveyor belt system. And the most similar system is the you could see the hot water in the cup, and this heat from the inner layers of the Earth is the convection of this is very similar, like the heat in water in the cups. As the mantle materials moves, it drags the plates of lithosphere along its surface, and this movement of lithospheric plates is known as the plate tectonics, and it is a process of extraordinary importance to our plate. The main 6 plates of our Earth is Pacific Plate, Indian Ocean Plate, Asian and European Plate, African Plate, American Plate, and the Antarctic Plate. And you could see the 6th plate in this area, in this picture. Here is divergent boundaries, and now we'll start to talk about the 3 different boundaries. The first one is divergent boundaries. Divergent boundaries, it is tectonic plates push apart from one another as magma rises upward to the surface, creating the new lithosphere as it cools. Let's look at this picture. These plates and these plates, they are pushing to the different directions and pushing from each other. And then the magma will rise and create the new lithospheres as it cools. For example, the Mid-Atlantic Ridge, part of the 74,000 kilometers system of divergent plate boundaries. It is slicing across the floors of the world's ocean. the rigid rift is formed here, and the rigid also forms in these boundaries. Let's look at the tailings first. Tailings is portions of ore left over after metals have been extracted in mining. So it is reused tailings to make slag cement, or even glass and ceramics. So even the tailings are very useful if we reuse it and to make other products. Let's go on talking about another boundaries. It is the convergent boundaries. The area where tectonic plates converge or come together. What that means is that actually there are three different kinds of the convergent boundaries. And the first one is that you could say it is the oceanic crust and the continental crust. They converge into each other, and the oceanic crust will go under the continental crust because the density of the oceanic crust is higher than the continental crust. And then it will form the subduction here. Let's look at this arrow, the subduction here. The subduction here will squeeze the magma to come out and then form the volcano here. The second kind of convergent boundaries is between the continental crust and another continental crust. And when the two continental crusts come together, it will form the collision mountains, and the subduction also exist here. The third kind of convergent boundaries is between the oceanic crust and the oceanic crust, which I didn't show it in this picture. And this kind of convergent types, it will form the sea mountain in the ocean. Convergent crust can result in the subduction or the continental collision, as I had already said. Let's look at the transform boundaries. Transform boundary is the area where two tectonic plates meet and slip and grind alongside one another, and creating the earthquake. Let's look at this picture. This plate and this plate, they are moving in the different directions, and it will form the strike and slip fault here. For example, the Pacific plate and the North American plate rub against each other along the California's San Andreas Fault. Let's look at the subduction that I had mentioned before. Subduction is actually the plate tectonics process, by which denser crust slides beneath the lighter crust at convergent plate boundaries. It also exists in the other kind of the convergent boundaries. For this subduction, sometimes it will often result in the volcanism, like this picture shows. The subduction oceanic lithosphere here, and it will form the volcanism on the land. Very interesting. The Venus and the Mars, it do not have the subduction area, and from now, the scientists only found that the subduction area only exists in our Earth.